Good day everyone, and good day also to Ma'am Mel, our instructor for the subject AG206 Biochemistry. We are group number 5 from section B, and for this video, we are going to present our very own soap made with our own choices of additional ingredients. Together with me and my group, we will discuss how we made our soap and what benefits it may give when used, considering the addition of ingredients or additives of our own choice. We will also discuss what makes our soap formulation unique from other groups, and the effectiveness of our soap is yet to be revealed. So, keep on watching! Before anything else, we will first introduce the name of our soap. Esther's Secret ADM x2 Moisturizing Soap by Group 5, Section B. We named our soap basically from the members' names that consist the group, starting with Esther A. Eno, Aiza T. Amper, Danica Simafranca, Matt Louis P. Mosca, and Melly K. Tero. So here's Matt Louis Mosca to discuss the materials and equipment used in the making of our soap formulation.
So good morning everyone, my name is Matt Louis Pialago Mosca, taking a Bachelor of Science in Agriculture, major in Animal Science. So my topic in laboratory soap making is materials and equipment. So the material that used in the laboratory of soap making are beaker, stick blender, dishwashing liquid or sponge, soap molder, watermelon, tissue paper, dropper, gloves, lab gown, oils, distilled water, black cloth, pitcher, plastic spoons, sterilizing glass or ROD, spatula, weighing scale, water, pure scent, and phenoxyethanol liquid.
For our soap ingredients, we used 150 grams of palm oil, 150 grams of coconut oil, 250 grams of olive oil, 209 grams of water, 42.970 or 43 grams of lye or NaOH, and 3 to 4 drops of phenoxyethanol liquid. For our additives, we used watermelon extract for 85.8 or 86 grams and watermelon pure scent for 3 drops. The group decided to add watermelon extract as to complement the watermelon pure scent provided to us by our instructor. Watermelon extract for skin can help make your complexion look younger, firmer, and utterly glowing, as it is rich in potassium, amino acids, and vitamins A, C, and B. Thanks to its high water content, this fruit is extremely hydrating and can even minimize the appearance of fine lines, wrinkles, and age spots. We believe that this is what makes our soap unique from other groups, along with its color and softness texture before and after use.
And now, I'll discuss the fatty acids present in our soap and what is the rule in our soap formulation. So, lauric acids. So, the role of lauric fatty acids in our soap is that lauric has the ability to create a rich, creamy lather. It also has antimicrobial properties that help cleanse and purify the skin. And additionally, lauric acid can help stabilize the soap and prevent it from separating or spoiling. Next, fatty acids is linoleic fatty acids. So, linoleic fatty acids play an important role in our soap. Helps to provide conditioning and moisturizing properties to the soap and creating a hard, long-lasting bar of our soap with good lather and moisturizing properties. Next, fatty acids is linolenic acid. The role of linolenic acids in our soap is to provide hardness and cleansing properties. Linolenic acids is an essential fatty acid that is important for maintaining healthy skin. It helps to remove dirt and impurities from the skin, making it an effective cleanser in our soap making. Next fatty acids is myristic acids. Myristic fatty acids is to produces a hard white bar with good lathering properties. It also helps to stabilize the foam and improve the textures of our soap. Next is oleic. So, the role of oleic acids in our soap is to provide conditioning and moisturizing properties and also contribute to the hardness of the soap. Oleic acids is a monounsaturated fatty acid that is derived from vegetable oil such as olive oil. Next is palmitic acids. Palmitic fatty acids in soap provide hardness and stability to the soap and also contributes to its cleansing properties. It helps to create a dense, creamy lather that effectively remove dirt and impurities from the skin. Next is ricinoleic fatty acids. Ricinoleic acids in soaps provides conditioning and moisturizing properties, so contribute to the soap lather. It helps to create a creamy and stable lather that is gentle on the skin. The last fatty acids that present in our soap is stearic. So the role of stearic acids in our soap is to provide hardness and stability to the soap and also contribute to its cleansing properties. It is a saturated fatty acids that helps to create a dense, long-lasting lather in soap. Stearic acids also helps to reduce the stickiness of soap, making it more pleasant to use.
Procedure. So step 1. Prepare all the ingredients and laboratory glassware and equipment. Use gloves, face masks, long sleeves, and closed shoes when doing this lab activity. Step 2. Sterilize your pre-washed towel or cloth for soap insulation process through steaming, and only secure the sterilized towel or cloth in a clean plastic. Step 3. Clean the soap molders or containers and glassware with dishwashing liquid or paste. For the final rinse, use distilled water to remove impurities and use a paper towel for wiping. Step 4. Weigh and combine olive oil with 250 ml, coconut oil 150 ml, and palm oil 150 ml. Set it aside in a larger and clean plastic container, which is the pitcher. Step 5. Measure 209 ml of distilled water using a graduated cylinder or beaker. Step 6. Weigh 42.970 grams of NaOH using a pocket weighing scale. Step 7. Slowly add NaOH or lye to the distilled water while gently staining until the NaOH is fully dissolved and the liquid is clear. Let it cool down for a few minutes. Step 8. Slowly and gently pour your lye water into your oil mixture. Step 9. Pulse the steak blender a few times and watch as the oils and lye start to combine. Switch between short pulses and stirring with the blender until the mixture comes together to the lightness or the liquid thickness. Step 10. Working quickly, stir in the essential oils of fragrance oils, 1 drop of phenoxyethanol and other additives. Step 11. Once your soap reaches about a medium trace, or which is the liquid thickness, pour it into your mold. Scrap the container using a plastic spatula to ensure no soap is left behind. Tap the molds on your table or counter to release any trapped air bubbles. Step 12. Insulate the molder by covering it with a sterilized cloth to allow the soap to sit in the molder for 47 to 72 hours or 2 to 3 days at room temperature. Step 13. Unmold the soap, weigh a sample or initial weight, and allow to cure for 7 to 10 days. Then weigh a sample again to see if there are any changes in terms of weight. And after the curing process. Last step, Pack the soaps with your desired soap packaging. Soap should be ready to be used after the curing process.
Esther's Secret EDM Moisturizing Soap Survey Results. Respondent number 1, Shalame Sensoles, BSF2. Effectiveness, she gives 8. Other and conditioning, she gives 8. Cleansing action, she gives 9. Fragrance, she gives 7. Her personal feedback comments. After 3 days of using the soap, I've observed that my skin is very soft and smooth. It is very comfortable when using and it is very effective when cleansing, although the fragrance is not very strong in smell. Respondent number 2, Gian Marcusa, BSF2. Effectiveness, she give 8. Lather and conditioning, she give 10. Cleansing action, she give 10. Fragrance, she give 8. Her personal feedback comments. After 3 days of my observation, in your soap, it is smooth. Though it doesn't have much fragrance, it was still nice for the skin.
So another respondent, which is the respondent number 3, Jeremy Babor, BSF2. In her ratings, during the 3 days of survey, she rated effectiveness of soap as of 7/10, lather and conditioning of 7/10, cleansing action 8/10, and fragrance 7/10. She also gave a personal feedback in which she said that your soap is a natural kind of soap for me. Although it doesn't have much fragrance, but it is nice to use it because it can smoothen the skin and also it has a great amount of lather when used. So, respondent number 4, Raymart Giselle, BSF2. He rates also the Esther soap as effectiveness of 8/10, lather and conditioning 9/10, cleansing action 9/10, fragrance of 7/10. He also gave a personal feedback or a comment of, after 3 days of using your soap, I observed that it is nice to use it because it has much lather and it is nice also for the skin, although it doesn't have much fragrance. And last one, respondent number 5, Darrell B. Dumao, a BSF2. He also gives a rate of effectiveness as 8/10, lather and conditioning 7/10, cleansing action 9/10, fragrance 8/10. So he gave also a personal feedback and he said that based on my observation in this soap, it appears that the soap has been effective in keeping my skin clean and fresh. So that's all and thank you.
Conclusion. Based on our observations and findings during and after the experiment, the group therefore concludes that making our soap by first measuring the fats and oils, water, and lye or NaOH with the exact measurement based on our procedure. After mixing the lye or NaOH into water, we find out that the lye mixing in water goes hot, and while stirring quickly and continuously, we also observe that the lye dissolving in water turns into a shallow grayish water. The group learned that in mixing the NaOH in water, the one that is poured should be the lye or NaOH into the water and not the other way around. This is because it can cause an explosion and pose a risk for external and even internal injuries to the person doing the task or to nearby people. Also, during the mixing of the 3 types of fats and oils that we use in our soap, we found out that the olive oil did not dissolve with the coconut oil and palm oil. It remained on top. In addition, when mixing the overall ingredients, the first thing to put into the pitcher is the NaOH dissolved in water, followed by the fats and oils, and finally, the phenolacethanol liquid, which should be dissolved before adding the additives, which are the watermelon extract and the watermelon pure scent. and stirring it slowly until it melts. This now creates our own soap with our own choice of ingredients and additives. And based on the results gathered from our respondents, we concluded that our soap lacks fragrance and it's not very strong, but it makes their skin smooth and soft upon use. They also mentioned that our soap gives more lather and is very effective when it comes to cleansing. Overall, our soap's effectiveness obtained a high rating from our respondents.
These are some photos of the final product of our soap with the packaging.
Reflection. So in reflection, we have learned that the overall activity of soap making was fun, but at the same time, it is very challenging. This activity taught us not just how soap was made, but also how important the teamwork in engaging activities that involves following procedures and at the same time, considering safety in performing experiment which has compounds that can externally cause skin rashes and even internal injuries. At the same time, doing this experiment is very expensive. We really need to have enough money to buy overall ingredients which are very needed in order to accomplish the experiment. It requires a lot of time, effort, being more resourceful and knowledgeable to perform the activity. We have also learned that to integrate biochemistry and agribusiness in soap making, the following steps can be taken. Number 1. Determine the type of fatty acids to be used in the soap making process. Number 2. Source the agricultural products that contain the desired fatty acids. Number 3. Extract the fatty acids from the agricultural products through a chemical or mechanical process. Number 4. Combine the fatty acids with an alkali such as NaOH in the appropriate portions and temperature to initiate the saponification process. Number 5. Allow the mixtures to react and eventually solidify into soap and glycerin. Number 6. Cut and mold the soap into desired shapes and sizes. And number 7. Package and label the soap for sale or personal use. In the overall, the integration of biochemistry and agribusiness in soap making involves understanding the chemical process of saponification as well as sourcing and utilizing agricultural products to obtain necessary fatty acids for soap production. And that could be all. Thank you.